Hello, everyone, and welcome to the next lecture in AI concepts. Today, we are going to talk about maxima and minima of a function. What is it, and how is it related to machine learning, okay, or artificial intelligence? As the name suggests, maxima means maximum value, minima means minimum value. Of what? Of a function with a value with a single variable x or c. Okay, so how do we find it? Now we know what is maxima and what is minima. See, so it's the point on the graph, the maxima, where the output value, the y-axis, is the highest compared to its neighbors. Okay, within the given interval. Now this is important. Within a given interval. So given a range of values where a y, given a range of x where y is maximum. Okay, so in simple terms, it's the peak of the curve. Now, what is local maxima? Local maxima, see, there are two things, local and global. Okay, related to both maximum and minimum. Okay, sorry, this is minimum. We'll typo error. Now, local maxima is where f of c, where c is any value, is greater than, so it's maximum, right? So it's greater than any value of x in a small interval around c. So plus or minus 3 or 4 points here and there, okay? Global removes that range, the interval. So f of c is greater than or equal to for all values of x in the domain of f. Okay, so when you say local maxima, it's only the highest point within a given range. Okay, when you say global, it's the highest point for the entire data set of x. Minima is just opposite. It's a point in the graph where the function's output value is the lowest compared to its neighbors, okay, within the considered interval. Again, it's local minima within the small interval where the value of c is less than equal to for all the values of x within the given interval c, and it is the global when f of c is less than all the values of x in the domain, the entire values that x can take. Let's see an example. Okay, so now this is the highest value and the lowest value in the graph. Okay, so let's take a function y. Okay, f of y is equal to 5x3 plus 2x squared minus 3x. Simple function. How do we compute the global maxima and minima? There are two steps. First, you take the derivative of the function, the first derivative of the function. So if you have to take the first derivative of the function, what you do? Multiply 5 by 3, reduce x by 1 factor, so becomes 15x squared. Here multiply 2 by 2, which is 4, and since we took 1 here, we reduce 1x. So first it was x squared, now it is just x, and minus 3, okay? Because here it's x raised to 0, or x raised to 1. Okay, so 3 divided by 1 is 1. Oh, sorry, 3 multiplied by 1 is 3. So the derivative is 15x squared plus 4x minus 3. 15x squared, 4x minus 3. So that's the derivative. Now, what we do is, which is the quadratic with zeros at x, if you compute that, solve this quadratic equation, you will get two values of x, minus 3 by 5 or plus 1 by 3. Okay, so these two values of x will satisfy this equation. Okay, but the second step is to find the second derivative of this function, of So second derivative is taking the derivative of the derivative. So here again, so 15 multiplied by 2, which is 30. Now, since you took 1x here, you divide x by x, you divide x squared by x, so you get just x. Here, it's just x raised to 1, so 4 times 1 is 4. X goes away, x by x goes away, there is nothing here, so you get rid of this. So the second derivative of the function is 30x plus 4. Now here, see here, we computed two values of x here. X could either be minus 3 by 5 or x could be positive 1 by 3 or 1/3. So we substitute here. So at x minus 3 by 5, the given value of x is minus 14. It is less than 0. So minus 3 by 5 is the local maximum. Okay. And at x 1 by 3, okay, the value is 14, which is greater than 0, which is, so 1/3 is the local minimum. So here you can see what it is, plotting on the graph, the maxima and the minima of the function. So what you do, given the equation, okay, given the quadratic equation, first you find the first derivative, solve it by taking x is equal to 0 and see what comes up to. You get the values of y, you get the multiple values of x, which satisfy the equation. Take the second derivative, substitute the values of x there, and you would have your local maxima and minima. Okay, and this is all for concepts. You will have all the models and everything which will help you compute or give the values of all these. Now, where it is used in machine learning. Okay, it is, see, we are trying to find the maximum or minimum of a function. So we use it in loss function optimization. Loss function is nothing but the cost function, okay, of a model which we use it while training it. So we try to minimize the loss, okay. We try to find it using the gradient descent. We use the maxima and minima for regularization techniques during L1 and L2 regularization or regression. We use it for hyperparameter tuning. Hyperparameters are parameters that are not learned during training, but set before the training processes. Okay. We use it using model selection. Which model gives us the best value, which has the lowest cost function. It is also used in the activation functions in neural networks. Okay. Activation functions such as ReLU, okay, rectified linear unit, have regions of maxima and minima in them. Okay. Understanding these points helps in analyzing the behavior of the neurons during training, okay, and ensuring the training processes. So this was a short video explaining what is maxima and minima of a function and its usage, where it is used in machine learning. That is all for today. See you all again in the next lecture with some new concepts of machine learning. Until then, happy learning. Thank you for your time.